All right. You are here for Chem 101 Environmental Chemistry course. So we will be going through materials in the textbooks throughout the semester. All right. So let me share my screen and go through details. I have to select the course. Can you see my screen now? I will go into home screen now. You must have, you must be able to go to Canvas and look into this page, okay? I need to do something else to make sure that what you see is okay. All right. Can you see my web page now? Yes or no, please?
Yes.
Okay. There are modules that describe the various topics in the course. First, you go to modules 1. How many of you have gone there already? Have looked at it? Anybody? Okay. I'm going to the module 0. Okay. I have given the course overview about me, how to contact me, and my email address and phone numbers, about your instructor section, modules, introduction to module 0. Now I'm going to go through syllabus first. Go to syllabus, you will be seeing a page like this. You can make it bigger like this. And basically, it describes the course. Learning objectives. The textbook is Chemistry in Context, 9th edition by American Chemical Society. You could use 10th edition or 9th edition. You could buy the book online from the site here, Magro. I think it is, I forgot the book seller, who's that. I will send you an email how to get the book online, okay? So the course content we cover in Chem 101 is based on chapter 1 through 9, 1 through 8, basically, 1 through 8. The first test is based on module 1, that ends up with test 1, covers chapter 1 and 2. and Module 2, Chapter 3 and 4, Module 5, 3, Module 3, Chapter 5 and 6, Module 4, Chapter 7 and 8, so on. We have a final exam covering Chapter 1 through 8 at the end of the semester. The grading scale is shown here. You can read it. You have four tests, 1 hour test, 4 of them will give you 50% of your points to your grade. Final exam counts 20% to your final grade. Canvas quizzes and class attendance consist of 30%. And there's a bonus paper assignment. You can get 10 more points. So final exam is given at the end of the quarter. I will announce the dates. So tests will be mainly online. I will send email about the time slots close to the exam test, and you have to take it over in the Canvas. I will give you passcode. First you sign on to Zoom, and then I check your identity, and then we'll give you a passcode. So class attendance requirements are there. I know some of you are working and cannot come to the Zoom meeting, but I have a recorded Zoom meeting. You should look into them and show that you are watching them regularly. So I will, if you do regularly attend the course Canvas web page, I can see that. So there are a lot of statements, disability about and education rights, etc. Do you have any questions about the syllabus? I guess no, huh? All right. I escaped from the syllabus. I had to go back to calendar now. This screen sharing is a pain. Okay, you went back further down. Okay, course calendar. The events that take place in the course during the semester is outlined here. So basically it shows the dates you attend the classes in green and days which you take the test is outlined. I will update this one as soon as I possible about the other events, chapter dates we cover the chapters, etc. All right. So please look into this to get to know about more courses, more about the course material. So there's a GE survey, General Education Requirement Survey, to assess learning during this class, how much you learn before and beginning and the end of the course. So this is not counted for your grade, but I will give you bonus points for taking it. 10 points. Okay. So please take it before September 24th. Okay. I outlined Zoom meeting, the previous course Zoom meeting on August 16. Now I am going to update with this Zoom meeting for August 19. Okay. Today is August 18. It will be updated. So module 1 is, do you have any questions about the course now?
No, sir.
If you have any problem, send me email, okay? You can send me an email at any time if you have any questions, or call me, okay? All right. So the module 2, module 1 covers chapter 1 and 2. So details are given here. Today I'm going to start on chapter 1. Before chapter 1, we have an introduction to chemistry. Because this chapter 1 just jump into stuff directly. I need to talk about chemistry in general and scientific method. So that part I'm going to talk today. Okay. Let me go to PowerPoint site, introduction to chemistry. Now, at any time you want to review, there's a video on my PowerPoint on introduction chemistry. So therefore you could go back. So the first class meeting video in the spring semester is here. I'm going to update with the first meeting for this fall 21 semester. So it will be updated as we go through the course. Okay. Now this is the first day of class meeting for dealing with chemistry, introduction to chemistry. How many of you can click on, have gone through this little bit, clicking on this course material? So please do that after you gone out of this Zoom meeting. Now I want you to do me a favor. You go to chat box. Already there are chat box. Some 6 people sign up, send something to me. Now I want you to print your name, full name, last name first, last name, then it doesn't matter, I can figure that out. But it will be helpful, last name first and the first name last. So just type that on your chat box. How many of you see a chat box in your Zoom meeting? Bottom of the menu items.
You said the chat box?
Yes.
Yeah, I see it.
So I will get the names from the chat box and give you credit for attending the class. All right. Today 13 people showed up. So I need 13 names put on chat box, type it in the chat box. Okay, your name. All right. So I'm going to share my slides on chapter 1. Can you see it now? My PowerPoint slide, first page, title page.
Yes.
Okay, good.
Yeah.
All right, let's go through this again. My name is Upal Sirivoden. Okay. I'm your instructor for CHEM-101 full coder. So you could be reach me at following email addresses or call me. I will respond to you as soon as I get your email or if you call me. All right. The first test is going to be on September 8th. It's on the calendar. And it covers chapter 1 and 2. And chapter 2, test 2, test 3, test 4, followed by test 1. Final exam covers chapters 1 through 8. All right. Introduction to, it will describe scientific method, atomic theory, and structure of matter. This scientific method is important for any science. Chemistry is one of the areas in the science, one of the fields in the science dealing with irreversible change of matter change. Then we describe them in terms of experiments using scientific method and using atomic theory and models of matter, atoms, molecules, ions. When you're dealing with chemistry, you always talk about atoms and molecules and ions. So the matter is composed of, matter is in the form of solid, liquid, and gases consist of atoms and molecules and ions of various elements. Chemistry is a science that tries to understand how changes of matter take place. So we apply this knowledge to discuss the environment, changes in environment, and to come up with solution using models, atoms and molecules, and how they behave. Environment is a very complex combinations of various factors. So climate, soil, and living things. So environments ultimately determine our form and survival. So just look into video in the section video in chemistry and environment to just get an idea about how the environment is dealt by chemists, environmental issues. Chemistry being a science, we use scientific method. Opposed to philosophy, scientific method is based on experiments and facts. The philosophers are the people who have some knowledge about the world, come up with ideas based on reason. So they are basically bypassing the facts. Then knowledge is the important thing. But the knowledge is based on facts, then it's okay. So, but we scientists base knowledge on investigation based on facts, come up with knowledge and theories to describe the world. The scientific method is composed of various steps. Oh, okay, okay. Please sign the chat box with your name, okay?
Okay, I already put it in there, but didn't we do it
Okay.
again?
No, that's okay
Okay.
if you're done it. Okay, scientific method is based on several steps. Normally it starts with observations. So it could start with experiment, then followed by observation. To describe observation, we come
Oh, can
up
I
with,
me?
yes, you have a question?
No, sorry.
Okay. So hypothesis is a explanation of, tentative explanation of observation. Then hypothesis become a theory when it's confirmed by many scientists. So experiment is the first step in chemistry. Experiment, the scientists do experiments. They also come up with laws. Laws are description of observations, like pressure increase with temperature for gases. So laws become part of experiments that leads to hypothesis. So there are 6 steps here, like observation, experiments, hypothesis, theory, law, 5 steps. You need to know about them. Like I said before, science is empirical. It's based on fact, numbers. They're not imaginations. So on reason, like philosophers does. It involves decision making, problem solving strategies. So when you do troubleshoot, it basically involves looking at the problem and doing the experiment, figuring out your problem and come up with solution. The terminologies used in scientific method is facts, scientific laws, hypothesis, theory. So please check on the video on steps in scientific method in the link in the PowerPoint. I will go through about,
Excuse me.
yes.
What is it? What do you mean by not a lockstep approach?
It is not a fixed approach. It depends on the problem. You know, we change plan. So it's not it depends on the problem. That's why what it means by lockstep. So for every solution, there's no fixed way to approach. In biology, we approach problems differently than chemistry, all right? We deal with organisms, so approach is little different. We cannot use test tubes. Of course, we can grow babies in test tubes. No, that's a joke. So do you understand that what I mean by there's no one way to approach all problems. So it depends on the context. But the basic ideas are there, like experiments, collecting data, facts, coming up with a law, and coming up with the explanation, hypothesis, and finally a theory. Okay?
Okay, thank you.
Hypothesis is considered scientific. It must be testable. In principle, it can be proven wrong. Testable means you always come up with a hypothesis and it could be proven wrong. Data only supports the hypothesis. From the experiment, you get the data, then you come up with it. Opposed to theory, hypothesis is the beginning explanation. When hypothesis was tested many times, that found to be correct, you come up with a unifying explanation of broad class of similar problems into a theory. Is changes of matter could be explained in changes of physical state, could be explained by kinetic molecular theory. That means everything is composed of atoms moving with certain velocity, gases, liquids, and solids. So you start with specific problem, come up with a hypothesis, then hypotheses are proven for liquid, solids, and gases. Then you create a theory to explain everything belong to similar field. Matter is composed of atoms and molecules. Matter could be solids, liquids, and gases, like that. A good theory is also falsifiable. Theory could be proven wrong when new explanation, new data appear. So they modify. Theories become change over the time. So therefore, theories must undergo challenges to them over the period of time. The facts are data we gather during an experiment, a phenomenon about which competent observers can agree. So the data people all over can agree. So scientists need to produce conditions upon which data is collected to everybody through publications. So people could check the facts in many laboratories. Law, unlike in criminal law, is different. Law is relationship of natural quantities that has been tested over and over again and not been contradicted. For example, for gases, increase in the pressure, decrease the volume. That's a relationship, Boyle's law. Laws can be written as mathematical relationship or statement known as principles. PV is equal to nRT is a gas law. That's a mathematical relationship between volume, pressure, and temperature, and the moles of gas. So laws are dealing with data, relationship between different measurements of the same system, pressure, temperature. So it could be various data in different systems. Practical knowledge as the result of the sensors. We, based on our sensors, hearing, seeing, and we extend our senses to instrumentation. Instruments are our expansion of sensors. So we talked about that 5 steps, theories leading to theories. Laws summarize results of a large number of observations, pressure, volume, temperatures, etc. for gases. Observation could be made with naked eye. Observation emerge from experiments that rely on use of sensitive instrumentation. So we extended our capabilities through instrumentation. Observation is a description of some physical aspect of the world as a number or description. So there are quantitative and qualitative observation. Observation lead to hypothesis. So we're going through the same thing now. Results of an experiment may confirm a hypothesis or show it to be. Hypothesis could be falsifiable. So it could be proven wrong. The new hypothesis must also be tested through further experiments. Experiments and further experiments. Hypothesis and changing hypotheses lead to theories. Theories also are tested based on facts, so later modified or come up with new theories. Further experiment is very important part of in scientific method. So this is the progress that we made in science through continually changing our experiments, instrumentation, expanding our ways of obtaining various data, microscope, telescopes, all kind of things. Now we're going to talk about chemistry. Chemicals are ordinary things. When you heard about chemical, you think it's in the bottle in a lab in the chemistry department. It's not true. Everything is made out of chemicals in various combinations. Ordinary things are made out of chemicals. You don't look at that way, but that's the truth. Anything that can be held or touched is made of chemicals, various combination of chemicals. One of the first chemists to do experiments on matter is Antoine Lavoisier, a French chemist. He did an experiment where mass of a metal in air during burning, combustion is burning, mass of the metal increased because it's combined with metal and oxygen, produce metal oxide. That's our explanation now. People didn't know about that long time ago. They burn something in air, they pick up mass, they didn't know why. Now we understand there are metal atoms and oxygen in the air making a compound. Mass of an object is a measure of the quantity of matter. So mass of an object measures the quantity of matter. Matter could be atoms, molecules within it. Combustion means burning in oxygen. In a combustion reaction, mass of matter remain constant. So the combined mass of air and the metal was same. So Antonio Lavoisier came with the idea matter is conserved, mass of the matter is conserved in chemical reaction. This is an important idea about, this is a law. Mass is conserved. And Lavoisier measured mass of each container and its content before and after the body. Nothing, there was no change. Noting that there was no change in the mass during the combustion. So he came up with the scientific law that's dealing with observation. He came up with the idea mass before the reaction is equal to mass after the reaction. It's called law of conservation of mass in chemical reaction. In a chemical reaction, matter is neither created nor destroyed. Now, do you see that this is the first, one of the first scientific laws in chemistry before atomic theory came into being? Scientific theory is combining all the well-established hypotheses to form a basis for scientific theory. Theories provide a broader and deeper explanation of for observation and laws. There are models of ways, of the ways nature is, how nature behaves. They often predict behavior that extend well beyond the observation and laws on which they are founded. So one of the laws was conservation of mass. That was explained later by atomic theory. Theories are tested and validated by experiment. Over time, poor theories are eliminated and good theories, those consistent with experiments, remain. Classify the statement as an observation, a law, or theory. What do you think? When a metal is burned in closed container, the mass of the container does not change. It's a law or theory. It's a law. Observation. I think it's an observation. Matter is made out of atoms. That's a theory. Matter is conserved in, that's a law. When wood is burned in a closed container, its mass does not change. That's an observation. So there are observation, laws, or theory. So do you understand what I'm saying about different statements being one of the observation or law or theory? Okay? John Dalton, after Lavoisier, made his law of conservation of mass in chemical reactions, came up with a theory to explain the chemical laws. There were 3 chemical laws. After 2 more chemical laws came up with after Lavoisier. One, Lavoisier's mass is conserved. Second law is when in a certain chemical compound, compound is made out of two elements. The ratio between two elements is always constant. For example, water has certain percentage, certain mass of hydrogen and oxygen. So it's fixed, law of definite composition. Other one is law of multiple proportions. There are three laws: law of conservation of mass, law of definite proportions, law of multiple proportions. When two elements combine to form more than one compound, like carbon monoxide and carbon dioxide, there's a simple ratio between oxygen combined between these two, 1 to 2. Carbon monoxide has 1 oxygen, carbon dioxide has 2 oxygen. Therefore, it's called law of multiple proportion. Describe the various compounds formed by different elements, two different elements. So Dalton came up with a theory to explain these chemical laws. His idea is atom is the smallest particle of an element that can be identified as that element. Atom is matter, there are elements. Elements have fixed properties. They, like copper, iron, oxygen, their smallest particle is the atom, oxygen atoms in oxygen molecules. Atom once thought to be ultimate indivisible particles that make up matter are among the fundamental particles of science of chemistry. So initially, Dalton came up with the idea atom is indivisible, but he was correct only with respect to all matter was composed of atom. He was correct, but indivisible. He said indivisible, ultimate particle of atoms, different elements. Was wrong. Atom could be divided into neutrons, protons, and electrons. Slides. Okay. I will start with again next time when we have the Zoom meeting on Monday. All right. I'm not going to kill you today with everything in the class. You guys ready to quit? Are you guys there?
Yes, we're there.
Yes.
Okay. Please read the material on my webpage and listen to videos. Okay. I will continue from where I stopped on Monday. All right.
Okay.
Okay. Have a great day.
You too.
Please make sure you sign the
Thank you.
You too.
chat box. Okay. Take care. Bye bye.